end that are exposing these APIs. What they don't realize is that as the business grew and it's trying to offer more capabilities, people are creating a new set of APIs, layer that on top of existing APIs, and all of a sudden they have no idea what interfaces they have open. So this is a quote from Gartner. They believe that API breaches as an attack vector, APIs as an attack vector, is going to become the biggest attack surface area and the biggest way of attacking an organization. Here are some examples of recent API attacks that went undetected. And again, it's not that the tools aren't there, it's because most of the detection is done in a static manner. And when detection is done in a static manner, you're only looking at certain things that you already know about. You're not really discovering things that you don't know about. You're not looking at patterns. You're not looking at changing behavior. And when I say that these went undetected for a long time, Facebook went for 14 months. So that's more than a year. Google went for 2 years without detection. And these are not small companies. They have big security teams. And they are, well-known companies. They have good engineers. So it's not like, these are just some fly-by-night operations that didn't know what they were doing, right? So why does that happen? And you say, well, I already got my WAFs and my CDNs and my proxies and everything else. Well, that's okay. The problem is that API attacks really go through all of that. Not saying that those things are not important. Don't get rid of those. Those things are just as important because they are protecting you. But API attacks can go around them and they can exfiltrate data. And it's not always the hackers, and we'll see that. So what happens in a typical API attack? The problem is that you have legitimate or you have a bad actor masquerading a legitimate user. How do you say that happens? So I'll give you an example. We have a client in Europe that I can't name them because obviously they ran into this trouble. They are a financial institution, and what somebody did was they went there and they opened an account there. And they were a legitimate user. They're a customer of that financial institution, which also means that they have a username and a password. So they came home and they opened up their laptop and they connected to the website and interacted, got account balances, just interacted with the system. And then they sniffed all the traffic and they figured out, okay, what are the APIs that are being called? What does the payload look like? And then they went systematically attacking it and probing the system using the legitimate credential. So, legitimate user, they're a customer, but their behavior is not legitimate. And they basically start probing the system. So what happens is that they are bypassing any kind of regular controls that you normally have in the front end, right? So somebody would say, well, you shouldn't really have security by obscurity. I agree, but don't also say that obscurity is not a good security mechanism. These are all layered defense mechanisms. So obscurity is a good mechanism, just not by itself. So what happens is that now this bad actor is able to interact with the service, interact with the system, and exploit what a normal user would not be doing, because a normal user is just collecting, they're going to their account, they're interacting with that, and they're going away. But this actor is changing information in there. They might be enumerating all the accounts. And we've got multiple examples where this has happened. And it's not like, that somebody did that on purpose. It was just an oversight when somebody was programming that or coding that, because the API maybe was never allowed to be opened up, right? So we always tell people, we say, look, if you're gonna design an API, make sure it is designed as a finite state machine. How many people here know what a finite state machine is? Okay, good. So you'll be amazed how many times you ask programmers, application programmers nowadays, what a finite state machine is, and they have no idea. So that means your API should never, ever, ever be in a state where it's undeterministic, right? But because we don't have people who understand that, the reality is you get into undeterministic states. So USPS, what was their problem? They had an API that was authenticating actually. They did implement authentication. What they did not implement was authorization. So all you had to do was go in and change the sequence number, customer ID number, just randomly, and you could get access to somebody else's information. And this was part of their business API that they opened for large businesses to track spend and track delivery. And you could say, well, okay, so what's the big deal? Well, the big deal was that you could go in there and you could switch the type of account a business had. That means if you're a Netflix or a Gap or Amazon or somebody else who's shipping large volumes, somebody could come in there, find out that that was the Amazon account or the Netflix account, and change their account type so that their rates go up. So it's more of a cost the business money point of view, right? It was a denial of service, call it. T-Mobile, and this, we just put T-Mobile there, but this was relevant to every single provider. They had a API that was open for getting location information. And it was basically just an API that would send you an SMS message. You could go in there and you say, where is the location of this phone number? And they would send that phone number an SMS message saying, you know, do you authorize? And if you said yes, then they would send you then you show you the location. There's multiple things wrong with that approach. First of all, if my phone is lost, I'm not going to be able to approve the request anyway. So there's multiple things wrong with that scenario. But they did not even check whether somebody authorized or not. They just showed the location. So how that was used was, it was used to get information about users. All you had to know was have somebody's cell phone number and you could know their location at any given time then. Now, imagine what could happen with stalkers, spouses, ex-spouses. You know, you can just imagine the different things that can go wrong there. Facebook, we already know, there were two things that were going on there. One is a partner that was using the API in a bad manner. That means that they were operating outside of their agreement with them. So legitimate user, legitimate API key, everything was good, but the behavior was not correct. But Facebook also had another breach or potential breach where the friend API could be used to target and get information about your friend's friends, which means that they just have to get to one indirect level every time and then continue to expand from that. Again, it was just not coded correctly and there was no authorization. So how does that happen? So normally you have you know, a normal scenario where it's talked about, there is some protection because you're checking data, you're checking the models, you're checking the payload, you're capturing it, you're putting it, you're structuring the request properly. But the bad guys don't have to follow those rules. They can just get up in the morning and decide not to use the interface that you've provided. So by going around that interface, they've gone around every single control that you have put in your application. And this is one of the problems, is that as more and more applications are getting created that are custom applications for doing one thing and one thing only, the application writers, the application owners are thinking, oh, I've tested my application. But APIs are not getting tested. or when they are tested, they're getting tested in the context of the application that you're presenting to your users. But you're not testing the API for all the different ways it can be used, and all the ways that you never thought it could be used. And that's where behavior comes in. So I've got an example here. It's a recorded demo, a short demo of data exfiltration. So this is similar to what was going on in the case of USPS, and there was another breach, 885 million records, First Data, which was a title company. Their problem was they were worse than USPS. They didn't even put authentication in there. So what was going on there was, you go to closing, and you give a lot of private information during a real estate closing. All of that information gets uploaded, and so they have records from all these different closings, and they would give you a URL. So you would get this URL, and once you had the URL, you could access your information. The problem was, and that's what we're going to show here in this example, the problem was that all of those records were using a sequential number. So all you have to do was go to your browser's the bar there, and just increment or decrement the number by 1, and all of a sudden you have somebody else's private information from a closing set of documents. That's a lot of private information. You've got tax records, you've got information about their paycheck, you've got information about their credit, right? So let's see. So here what we're going to do is we're gonna kind of simulate the same thing, and what's going to happen is that we're emulating it using, we're using the Fire API, so it's showing as a patient record. But we're just going to change the number there and continue enumerating it. And so you can see that the backend API is just returning results as long as the query is done. So here we're gonna run that for 900 iterations, and we will set it so that it's below the threshold in case there is a system that is looking for a flood of traffic and a flood of requests coming in. So you can stay below that, right, and just go under the radar. And as you can see, we've figured out that something is wrong there. So a bunch of requests did go through, but then eventually it stopped, right? So it's not a 0-day stop, because remember, it's pattern recognition. So once the pattern is recognized, we can look to see what was going on with that token, because the token, the client was the same. So we can see, oh my God, all these requests are coming from the same client. Okay, so something is wrong. That is the forensic aspect of that. So quick demo, but it shows you that that attack could have been prevented, right? Maybe not for the first 50, maybe not for the first 100 accounts, but it would not have allowed 60 million accounts to be violated or breached, or 885 million records to be breached, right? So that's because it's pattern recognition. It looks to see what is a normal user behavior or a normal client behavior for that part of information or that type of information, and then what is abnormal. So we get this question a lot. Well, what about false negatives? What if this person was legit because they were an admin and they had to suck all this information and then push that into a database? That would be a legit use, right? They would be blocked. Yeah, probably. But what would you rather have? That once, one-off use case getting blocked, or not knowing what is happening? And even there, the system can be tweaked, because if you are doing that operation so many times, all the time, you can whitelist the token, you can whitelist the client, you can whitelist the user, to let them do those kind of events, right? So there are ways around that. So this takes us to what is it then that we're doing that is different? So it's really looking at the gaps that exist and using non-static rules to understand what is going on and looking at the security gaps that exist with an AI perspective. So what happens with API security today, right? This is what most people think about when they look at API security. Access control, WAF, put authentication in, put access control in, make sure you at least know who your user is, make sure that there is no major traffic coming in, so you have rate limiting or at least throttling or pushing back on that kind of stuff. But what's all the stuff that's missing? Whoa. Can you go back one slide? Thank you. I pressed clicker too many times there. So what is missing, right? What's missing is that what you still don't know is what is going on from a data exfiltration point of view. What is going on if you have a certain pattern that is happening, right? Because each of those activities might be okay, but when you do those activities in a row, that is a problem. So a perfect example of that is you log in, you say, I want to change my security question, I want to change my email address, my recovery email address, and I want to change my recovery phone number. Those are all legitimate things to do. But if you say, I forgot my password, if you say I want to change this, and then you say I forgot my password, and then you say I'm going to change my mailing address, and then do a shipment or do something else that is now using that new information, and it all happens in a sequence, well, potentially could be bad. But you wouldn't know that if you only looked at individual slices and not looked at the overall view of what is going on during that session and what happened prior to that session from the same user, from the same client, from the same token. So again, only AI-based systems can look at that because you're looking at a broad area. You can't write a rule that would capture that. It's impossible to write a rule that would do that. So most people look at API security and say, well, we've got these foundational things that every API security offering or when you're putting that in place. This goes everything from obviously what happens outside the application, so making sure that you improve the testing at the API layer. You make sure that there are, you do run code like a black duck or code analyses and look to see that there's no vulnerabilities or memory related or otherwise in the system, right? You can look for all your OWASP vulnerabilities. You can also look for making sure there is no overflows and all that kind of stuff. That's standard practice, right? But there are other areas that most people don't look at. What is happening in downstream from that? What is the behavior that happens once that initial part is done? Once you're already in the system, once you've already authenticated. If you're exposing a bunch of different APIs, so for example, take open banking. Open banking defines a set of APIs about getting the user's account information and consent-related information and where any kind of activity you want to do then on that account. So it might be okay to get the information, but then what happens afterwards? Each of those APIs could be surfaced as separate sub-applications or customized applications. So being able to know what is going on there and looking again to a pattern, that becomes important. Looking to see if you are seeing the same user and that their password is being used in different places. So you have different clients coming in from maybe possibly 2 different geographies, 2 different systems, right? But they're using the same credential. Well, why are they using the same credential? That is possibly because that credential is breached or that user account is breached and that user happened to use the same credential in different places. So that's a typical attack that normally happens for your partner ecosystem. Because if I'm using the same credential at Facebook and at Google and at Twitter, it's very possible that they also have common partners, and if the same thing starts coming in, attacking from the different partners or different starting points using the same user, could be a potential for misabuse. And then lastly, tokens. So currently, there is no way to do binding of tokens. There is a spec out there for it, but none of the browsers support it. So you can track stolen passwords, you can track stolen user IDs. How do you track a stolen token? There is no binding today. You can't do that. The only way to do that is to look at patterns and to look to see if other context around that has changed and does that still make sense? Looking at device reputation, looking at location, looking at what they're trying to do. The action is just as important. So the only way to really do that is, in our view, with an AI system, with machine learning, where you are constantly, the system itself is actually moving forward, right? Because you cannot write enough static rules. I'll give you another example. There was an insurance company, this was also out of Europe, that they provided insurance for fleet management, for large fleets. And all you had to do was put in the license plate of the vehicle, and they would tell you what the location was of the vehicle. So a local police department was using them for fleet management. Well, you can see where this is going. So bad actors were able to put in the license plates of the local city police department vehicles into this system and get real-time location of every single police vehicle.
Oh my God. That's dangerous.
So they knew, well, what the response time would be. If you're across town and there's nobody here, well, I can probably get around by doing something at this point. So again, it's an example of unforeseen consequences. And for us, this is why we say a machine learning model or machine learning system has three main steps. So you start with modeling everything. And this is why it takes a little bit of time for it to detect if there is a difference, right, between a normal pattern and an abnormal pattern. Right? But what it does after it figures out what the abnormal pattern is, once the detection is done, that's when you do blocking, that's when you do mitigation. Now, we have the ability to block things, but we can also give a signal back to an external system at that point, which can do other things from a mitigation perspective, right? And when we work with API gateways like WSO2, they actually get that signal back, and they can do, they can block at many more levels than what we are blocking at. So it's a very symbiotic relationship from that perspective. So we've talked about bad actors, and everybody just thinks that, okay, there's only one thing going on, and it's really that there's this bad systems. But like we just said, what is happening is not all actors are bad actors. You have misuse, you have abuse, intentional abuse, you have just a bad system where they didn't know what was going on. We have one customer that didn't know they had a misconfigured system. They deployed our product, the API gateway, and found out that one of their systems was misconfigured internally. And they didn't know that. And what that was doing was it was creating a lot more traffic on their network because of the misconfiguration. So it was costing them more resources, it was costing them more bandwidth, it was costing them more compute cycles, and it was costing them more Amazon hosting costs there was going up because of that. I mean, it was a misconfiguration. But now they were able to see what was going on there from that perspective. So the actual attack is just one piece, and that is key from an API perspective, because you have your landscape and your threat space is much bigger than just the attack. So I'll show you another video. This is a friendly, what we call the friendly fire. And in this case, it was basically a malfunction because a normal client would be getting the information from the backend service. We're still using the Fire API there. But what happened was that the client side was updated, it was misconfigured, and instead of having a record number, it ended up accidentally putting nothing in there. So the query parameter got changed, and it ended up being a null parameter instead of an actual record. So if you do a normal call with a record, you get the information back, and we're going to switch it to a null here. And what happens when you switch it to a null is that the system basically continues to process trash and eventually will time out. Right? So this is simulating what we saw. They didn't have a null parameter, but it's simulating what can happen that you wouldn't even know that that existed, because how was that going to be tested? Most probably it would never be tested down. So again, what we're able to find is it lets the traffic go for a while. It can start seeing what's going on there, but then it's going to start blocking. It's going to start blocking that particular token because it's saying, well, something is going on here, because for that particular token, I'm getting a lot of failures, or it's not, the behavior is not the same. If you put the information there, it returns back immediately. If you put null there, the system doesn't come back for 15 minutes or 5 minutes or whatever, right? Whatever your timer happens to be. So you can start seeing it's one attack, one token got blacklisted, so it gets put away, the total number of requests, and you can actually go in there at that point. You can see what for that token, that's the token that's on the blacklist, and you can see, well, why is it on the blacklist? So you can kind of dig into it, and once you dig into that, you can see that there was a null there. So you can see that the pattern has changed and something else was going on there, right? So that's the forensic aspect of the dashboard and being able to find that information. So it's not just blocking it, but it actually helps you debug and get information out of it so you can do the next step, right? Because if you're just being told, danger, danger, Will Robinson, and don't say, well, what do I do now? Then it's of no use. The next one I'm going to show you is, we talked about discovery right at the very beginning, that discovery is very, very important. So we'll show you a discovery use case here too. In this one, we basically deployed in discovery mode. And once you deploy it in discovery mode, it basically starts looking at all the traffic that is going through. So it sits in line and just looks at all the traffic. Once it looks at all the traffic, it starts building, so we're going to look at it for 24 hours there. It starts building a map and starts showing what are the APIs, what's the number of requests, and you can now start looking at it both from a user perspective. So we're going to go here to that particular user and see what request that user has made, right? This is all discovery. So this is starting with zero, not knowing anything, just starting from scratch. You can see what that user has done, what are the resources they have accessed, where they've come from, right? Or you could look at it from the API perspective and see which users are calling that API. So you can look at it from both from a resource point of view and also from a from a subject point of view, right? So full visibility. Okay. So what do we do together? Well, so normally you have your API gateway, you have your applications, you have your APIs. Where we work and we come into the picture, what we call sideband. So we're not sitting in line. We're not trying to do what WSO2 does, right? What we do is we have an integration or drop-in ability to integrate with WSO2's API gateway, and in that case, we get the information from WSO2 as to the API, the payload, and that information comes to us. This obviously, just one big box here, but it has a bunch of different boxes. It has a collector, it has a AI engine and a responder and all of that. So straightforward deployment. It doesn't change your network pattern at all. You continue to operate as you are. You drop this in and you get an AI ML based pattern recognition and a higher level of security, because now you can see things that you were not able to see. The other thing it also allows for is a concept of deception and a honeypot. So we can also set up a honeypot that is to look for attack patterns. So instead of returning back an error or returning back a deny, we basically take the request in no matter what, even if it's going to a backend system that doesn't exist, or if the query is coming in that shouldn't be serviced, we'll basically just take it in. We won't respond to it obviously, but we won't respond to it with a negative either. And what that does is we start looking to see a pattern emerge out of that, to see what is a typical attack against this particular API. If somebody's enumerating, if somebody is trying to change the payload, say from JSON to XML. So we can start looking at those things. So you've got WSO2 that is doing all of your access control, rate limiting, privacy, your message security, all of your encryption, signatures, scanning, validation, data validation, your payload validation. And then when you drop in intelligence for API on top of that, in that sideband mode that we were just looking at, what it starts now is you start getting more behavior-related activity and more behavior-related recognition of attacks that you can stop, that you will verify. So a lot of people also say, well, credential stuffing, for example. A credential stuffing attack actually does not want to do anything with your information at that particular place. A credential stuffing attack normally works where somebody has found a credential and a username, and they would basically run the same credential across multiple accounts, or a same username and a credential across multiple different back-end systems. And they'll do it so that it stays under the radar. And what you'll get out of that is whenever it succeeds, they basically just say, yes, that's a good credential and a good username credential pair. Then that is sold in the market as a valid credential for an attack that might happen at a later time. But with this kind of system, you can actually see when the harvesting was happening, rather than saying, well, the harvesting happened at some point, and I have no idea when the harvesting was done, and I'm only able to find this information when the actual attack or when somebody's trying to access information using that compromised credential. So you can actually see when harvesting is even done. So what we can do is we can block by user, by token, by API key, by cookie, or by IP address. Right? Those are the different macro level identifications that we can look at an API layer and verify that those things should be doing what they're doing or not. lastly, because of the dashboard that I was showing you, you also get this single pane of glass view, and normally you say, well, why is that important? Well, so that is important because you could potentially have multiple data centers, which means your APIs and your services, your backend services are deployed in different places. You also could be that you've gone through some kind of a acquisition or a merger, and as part of that merger, you might have different gateways deployed even, while you're in the middle of consolidating to WSO2. So, whilst you're doing that, you still need a single view of everything. Because otherwise, you're just, that's not like a 2-month or a 2-week or a 1-month thing. That could go on for, for a long amount of time. I think I'm losing my. Can you guys hear me still?
Yes.
Okay. Sorry about that. So, so having that dashboard through different, as a single way of looking at all the different clusters and all the different traffic is important, because remember, this is all about behavior, and the more information you have, the better you're judging behavior, and the better you're able to identify anomalous activity. So having the traffic come through every place and all of that traffic getting analyzed gives you a much wider picture. So conclusion, you can definitely detect those breaches much faster. You can get visibility into your API. It could not be just a breach, it could be misconfiguration, it could be bad coding, it could be misplaced setup on your network or your data. It could be misplaced access control rights, right? Actual attacks and hacking is a very small portion, it's only one of those 4 things. We've obviously won a lot of awards, and lastly, what we'd love for you guys to do is to try it for yourself. So go to that URL, and it'll help you get set up with a demo, and just look for the traffic. Look to see what you are able to see that was not visible before. I always tell people you can't prevent something that you can't see. So if you don't know about something, what are you going to do about it? Nothing. So try it. And with that, I'll open up to questions. Go ahead. I think there's a mic there.
So I have a question regarding this AI-based intelligence. So if I have, if I'm running my gateway, and then 2024, if there's a tag coming, and the AI detecting that, what to do? It does send a pager information to me to let the administrator know. So I come in and manually, disable the credential or remove the token, or it does it by own. That's my question.
Does everybody hear the question? Okay. So what it'll do is it'll do 2 things. One is it will actually do a block. So it will put that client and put it on the blacklist, and it will block. So it's proactive at that point. You can configure it only in detection mode, in which case all it does is just log everything, right? And then you can take that log, obviously, and then feed it out. So in the examples that you saw, we basically were actually feeding that to a Slack channel. We just did a Slack, and then Slack was notifying us, right? So you could take that to Slack, you can take that to PagerDuty, whatever you want to do. So you can do both things, and you can do them both at the same time also.
The other question, sorry, second question. The other question I had was for the customer you mentioned in your case. Did they use the gateway, or do they have a gateway, or they don't? Or if they have a gateway, did they deploy the security feature, at all, or just my?
So I gave you multiple examples. Which one are you talking about? The misconfiguration one?
Yeah, the customer can get the attack to be, the attacker pretend to be a user and keep sending requests.
Oh, yes, they had a gateway. Yes, they had a gateway because the user was a legit user.
Okay.
It was a valid credential, valid user, valid query, but they just started, probing the system at different points, and the system was looking at, they were just, because their gateway was only looking to see if your OAuth token was valid and if your user was valid, and letting it through, right? It was a legit, it wasn't, the traffic was not high, everything was legit, except that if you looked at it over a period of time, you start seeing, well, wait a minute, that behavior is not a normal behavior for a normal user.
Thank you.
Thank you.